2 years ago, scientists discovered dozens of massive sinkholes about 14 miles off the coast of Sheboygan.
600 feet wide. These are sinkholes at the bottom of Lake Michigan.
Several billion years ago, and could have contributed a significant fraction of the Earth's water that we have today.
Michigan, a state defined by water and shaped by ice, stands apart in both form and spirit with over 96,000 square miles. It is the only U.S. state made up of two separate peninsulas, the upper and the lower, joined not by land, but by one of the most iconic engineering feats in America, the Mackinac Bridge. Known as the Great Lakes State, Michigan touches 4 of the 5 Great Lakes, giving it more freshwater shoreline than any other state in the nation. Michigan shares its borders with 3 U.S. states and Canada and is wrapped in water like no other. To the north, across the Straits of Mackinac, the Upper Peninsula meets Lake Superior, the largest and deepest of the Great Lakes. This wild and rugged region, often referred to as the UP, borders Wisconsin to the southwest and shares an international boundary with Ontario, Canada to the northeast, divided by the icy blue waters of Lake Superior and Lake Huron. To the west, Lake Michigan separates the state from Illinois and Wisconsin, though ferries and shipping routes keep the connection strong. The western shore of the Lower Peninsula features charming lakefront towns like Holland, Ludington, and Traverse City, where sandy dunes meet orchards and vineyards thrive in the lake-moderated climate. To the south, Michigan borders Indiana and Ohio, where the land becomes flatter, more agricultural, and industrially connected. Cities like Kalamazoo, Ann Arbor, and Detroit form economic and cultural bridges to the heartland and the Rust Belt, each telling their own story of growth, innovation, and reinvention. But it's water that truly defines Michigan's essence. Lake Huron, Lake Michigan, Lake Erie, and Lake Superior hug the state, feeding its economy, shaping its weather, and filling its soul. From the Sleeping Bear Dunes to the remote Isle Royale National Park, from the shipwrecks of the Thunder Bay National Marine Sanctuary to the locks of Sault Ste. Marie, water is both history and future here. The Lower Peninsula, often called the Mitten due to its shape, is home to Michigan's largest cities and most of its population. Detroit, once the booming heart of the American auto industry, is a city of rebirth, blending grit, art, and innovation in equal measure. Grand Rapids, Lansing, and Ann Arbor contribute to Michigan's identity with diverse economies, universities, and vibrant cultural scenes. The Upper Peninsula, by contrast, remains largely wild. Dense forests, remote lakes, iron and copper mining history, and quiet towns define its rhythm. Winters are harsh, wildlife is abundant, and Yooper pride runs deep. Places like Marquette, Houghton, and Munising serve as gateways to the state's most untouched landscapes. Michigan's geography was carved by glaciers, leaving behind moraines, kettle lakes, and one of the world's most unique freshwater dune systems. Beneath the forests and farmland lie vast deposits of salt, gypsum, and even fossilized coral from a time when the region was an ancient sea. Have you ever wondered how a state split in two could feel so complete? What secrets lie beneath the waves of its inland seas or in the mines of its silent forests? Join us as we explore Michigan, a state of peninsulas and paradoxes, of industry and isolation, of lakes, legends, and limitless discovery. The silent depths, Lake Michigan's underwater craters. What could carve such immense, perfect wounds in one of Earth's largest freshwater lakes? That is the question now intriguing scientists and fascinating people around the world. Researchers have recently confirmed the presence of approximately 40 large craters lying silently at the bottom of Lake Michigan, each one an enigmatic mark etched deep into the lakebed. Lake Michigan, one of the 5 Great Lakes, has always been a realm of mystery. Its depths reach nearly 925 feet, and its surface covers over 22,000 square miles, a freshwater sea bordered by bustling cities like Chicago, small resort towns, and endless stretches of wilderness. Yet beneath its waves, the lake holds riddles seldom glimpsed from above. For centuries, local legends have spoken of strange lights beneath the water and mysterious disappearances of ships. Some indigenous oral histories refer to spirits present in the lake, with warnings not to disturb the deep peace at the lake's core. It was during a survey using sonar imaging that the unexpected was revealed, a pattern of vast circular depressions scattered across the lake's floor. Some of these craters are so large that they could easily swallow entire city blocks, measuring hundreds of meters across and plunging tens of meters deep. The sheer scale, 40 individual craters clustered within a defined area, immediately suggested that they were not formed purely by typical wave action or glacial scour. What then could have created them? Initial hypotheses ranged from ancient meteorite impacts to catastrophic natural gas explosions triggered during periods of dramatic environmental upheaval. Others considered the possibility that icy boulders, calved from glaciers at the end of the last ice age, might have slammed into the soft lakebed. Yet none of these theories fully accounted for the pattern's regularity and the crater's distribution, their roundness, their depth, and their tight grouping. Something about them resisted easy explanation. Geologists began to suspect an older story at play. Scientists at major research institutions across the Midwest, including teams from the University of Michigan, have begun a painstaking process of mapping, sampling, and analyzing each crater. Using remotely operated vehicles, they extract sediment cores from within these depressions, hoping to find pollen, minerals, or other traces that could tell the story of their origin. If these craters were formed by meteorite impacts, layers might hold evidence of shocked quartz, a rare geologic signal of collisions from space. If created by natural gas explosions, researchers would expect to find signs of combustion or residues of released methane. Initial findings reveal that sediment within the craters is distinct from the surrounding lakebed, suggesting that each depression is a kind of time capsule. In some cores, there are visible layers indicating major environmental events, preserved in sharp contrast to the more mixed sediment outside the craters. This suggests the events that form the craters were sudden and catastrophic. This, more than anything, fuels speculation and awe. Are the craters remnants of a time when the Great Lakes region was struck by meteor storms? Or are they evidence of ancient natural gas releases? Or were they formed in ways no one has yet imagined? Early exploration has found shards of mineral glass and sediment patterns unusual for the region, potentially signaling intense, transformative events deep in the past. Some sediment cores contain fossilized pollen, pointing to abrupt environmental shifts at the time of the crater's formation. Underwater surveys have even found microbial mats in the darkness of the crater walls, communities of organisms whose origins may stretch far back into geological history. Could these craters be the remnants of phenomena never before witnessed in a freshwater lake? Or do they speak to a prehistoric cataclysm in the bedrock of the Midwest? What's clear is that no other concentration of vast underwater craters is known from North America's inland waters. In addition, some coastal communities on Lake Michigan have reported subtle changes, occasional upwellings in waters near the crater area, or shifts in fish migration patterns, though these remain anecdotal. For now, the craters of Lake Michigan remain an open question, their silent presence a reminder that the world beneath the waves is stranger than anything glimpsed on the surface. What secrets might wait, sealed beneath layers of silt for thousands, perhaps millions of years? Unexpected turmoil, federal scrutiny, and the arrest of 2 scientists. not all Michigan mysteries lie beneath the water's surface. As discovery continues in Lake Michigan's depths, intrigue has reached one of the state's most respected institutions, the University of Michigan. The University of Michigan's Ann Arbor campus is a renowned center for research and innovation, home to world-class programs in engineering, medicine, and environmental science. In 2025, however, the university faced a troubling development. Federal authorities began an investigation after the arrest of 2 Chinese scientists affiliated with the university. The scientists were charged in separate incidents related to smuggling. While specific details were not widely released, the actions brought heightened scrutiny to campus. The news spread quickly, both within the university and across media outlets, and led to questions about research safeguards and the security of scientific data. Federal investigators launched a formal inquiry into the university's research protocols and international collaborations, seeking to determine whether safeguards had failed or if the incidents were isolated. For students and faculty, daily life was unsettled, especially considering the university's globally connected research in technology, health, and material science. It was a reminder that leading institutions, while being centers of learning and discovery, also operate within a complex global web where misunderstandings, missteps, or deliberate wrongdoing can have broad implications. Speculation circulated regarding whether these investigations had implications for sensitive or proprietary research. The university's leadership reiterated commitments to transparency and cooperation with authorities, aiming to ensure research integrity while protecting scholars' ability to collaborate openly. The incident prompted reflection within the academic community, both in Michigan and nationally, about how to balance openness, security, and international partnership in a world where information itself is often a critical resource. Awakening giants, seismic activity, and geological mysteries. At the same time, deeper forces beneath Michigan's land have begun to draw attention as well. Traditionally considered a geologically quiet region, recent years have brought surprising reports from geologists. Sensors and satellite systems have detected subtle seismic events in southern and western Michigan. While Michigan has felt low-level earthquakes before, usually minor and without significant damage, these recent clusters have prompted renewed scientific investigation. The estimate is that ancient dormant fault lines beneath the state may sometimes shift slightly, releasing minimal energy but providing important clues about the region's deep geology. Michigan's landscape was shaped by the passage of ancient glaciers and is underlain by a complex tapestry of bedrock and faults. Until now, most of these faults have remained inactive, buried under sediments, forests, and towns. But instruments now show that although large earthquakes are still unlikely, the earth beneath Michigan is not as still as once thought. Researchers from universities, including the University of Michigan, are now working to map these faint fault lines using seismic tomography, ground-penetrating radar, and sediment coring. They aim to understand whether recent patterns indicate meaningful change or natural random variation. Historical accounts, including local records and indigenous oral histories, have described rare shaking events in centuries past. Today's scientists compare these stories with data from modern seismic networks to better understand what the region's future might hold. Although there's no direct evidence linking the seismic activity to the underwater crater fields in Lake Michigan, the coincidence of mystery in both environments has sparked scholarly interest and debate. Could there be connections between subterranean movement and ancient lakebed cratering? It's a question researchers continue to explore with caution. Michigan is home to vital infrastructure, and even minor earthquakes could impact pipelines, bridges, or water systems. For residents, the idea of shifting ground in a state known for stability serves as a reminder that even the heartland carries its share of hidden risks and potential revelations. Nature nature's rhythms, the emergence of periodical cicadas. While scientists grapple with the region's geological and institutional upheavals, Michigan's forests are preparing for a dramatic event of their own, one that speaks to deep evolutionary cycles and nature's remarkable timing. Periodical cicadas, those odd wonders of the insect world, are famous for their mass emergences every 13 or 17 years. Their synchronized appearance is a marvel that draws fascination every time it occurs. While the most significant emergence in 2025 will take place in the southern United States, neighboring states such as Indiana and Kentucky will be visited by Brood 14, one of the largest and most studied periodical cicada broods. Michigan itself does not host Brood 14 directly in 2025, but its scientists and naturalists closely monitor such events in nearby regions. The last major emergence of Brood 14 was in 2008. During that time, forest canopies resonated with the chorus of billions of cicadas, an experience both mesmerizing and, for some, overwhelming. Cicada nymphs spend more than a decade silently feeding on tree roots before emerging en masse, shedding their skins and living only a few weeks as adults to mate and lay eggs before the next cycle begins. Why do cicadas wait so many years to emerge, and what triggers them? Their timing is a successful evolutionary tactic called predator satiation. By coming out in such vast numbers, cicadas ensure that no predator could possibly consume them all, guaranteeing a new generation survives. This intricate dance between insect and ecosystem continues to puzzle and delight researchers. Michigan's southern forests occasionally witness the fringe effects of cicada emergences, and local scientists contribute to broader research efforts that study cicada behavior, distribution, and the impacts of a changing climate. Warmer temperatures and shifting precipitation patterns have begun to alter some emergent cycles, with some nymphs appearing off schedule and vulnerable to predation or hardship. Despite these challenges, the life cycle of the periodical cicada remains one of nature's most reliable and spectacular calendars. Some observers use these mass emergences and their changes as indicators of ecosystem health. During these periods, citizen science thrives. Local communities across the Midwest join tracking projects, count cicada shells, and monitor their songs. These contributions help entomologists map patterns of emergence and adapt conservation strategies as needed. The sight and sound of periodical cicadas remind us that the deep rhythms of nature continue, often beneath notice, and that Michigan's forests, even when not at the epicenter of major emergences, play a vital role in the great cycles of life. Digesting the unseen, new insights into neurodegeneration. Amid the state's wild places and shifting sediments, another kind of breakthrough is quietly taking shape in Michigan's laboratories, a revolution in understanding the brain's deepest mysteries. At the University of Michigan, researchers are forging new perspectives on neurodegenerative diseases, including Alzheimer's and Parkinson's. These conditions challenge scientists and clinicians around the world, affecting millions and defying easy answers. Traditional approaches have long focused on the buildup of harmful proteins or unraveling genetic risk factors. Michigan scientists are now looking beyond these conventional views, examining how the brain's own repair systems might be activated or supported to slow or halt the progression of degeneration. This includes studying molecular pathways that help neurons clear waste proteins, maintain connections, and protect against stress. With advances in imaging and biochemistry, the team has begun to highlight new mechanisms governing brain health. Innovative live imaging tools can reveal how brain cells process damage and initiate repair. Some avenues of research include using gene editing technology to boost protective responses within neurons. While these studies are still at an early stage, the hope is that new therapies might one day help prevent slow, or even partially reverse forms of cognitive decline. Scientists are cautiously optimistic, and their work is already shifting how experts frame the challenge of neurodegeneration, from an inevitable decline to potentially a treatable, even partially preventable, condition. For many, these research efforts symbolize Michigan's role as a driver of scientific innovation, a place where basic discovery and hope for millions might begin in the unlikeliest of places. Vast frontiers, Michigan's place amid transformation. As Michigan's modern story unfolds, told in sediment and song, laboratories and wild woods, it becomes clear that the Great Lakes State is in the midst of profound transformation. The striking discovery of underwater craters in Lake Michigan challenges our ideas about North America's interior landscapes, leading to new views on ancient environmental disruptions. Are these features the traces of cosmic collisions or explosive forces that have long since ceased? Could they point to episodes of drastic geological upheaval, moments that shaped not just Michigan, but the entire Great Lakes Basin? Meanwhile, as federal investigations ripple and researchers delve into the deepest puzzles of biology and geology, Michigan's leading institutions find themselves at a critical juncture. The challenge is to sustain the spirit of open inquiry and public trust amid rising scrutiny and complex new risks. The state's legacy of discovery remains alive in its universities and field stations, places where curiosity is nurtured and new questions constantly emerge. Nature's cycles continue too. Cicadas rising from the soil, subtle tremors shifting the land, forests reawakening every spring and autumn. These events remind us that even as the world changes, there is continuity in nature's ancient rhythms. What will Michigan's next great discovery reveal? As scientists peer into the unknown, beneath lakes, through layers of earth, and in the human mind, one truth emerges. Michigan is shaped by mystery, resilience, and the restless search for knowledge. Will the next finding rewrite our understanding of geology, life, or the human mind? Which new question, sparked by the latest shock, will guide tomorrow's search for answers? In Michigan, the unknown waits just beneath the surface. Which aspect of Michigan's unfolding story stirs your curiosity most? The underwater craters, seismic activity, the hidden dramas of science, or the quest to heal and reveal? Share your thoughts below. What discovery do you hope is next in the heart of the Great Lakes? Stay tuned for our next exploration of Michigan's mysteries, where past meets future and the ordinary gives way to the extraordinary. Subscribe and turn on notifications for more stories from the frontiers of science, history, and wild landscapes where discovery is just beginning.